Our senior discussion.
All right, guys. So just that we're on the same page moving forward here. If this is a schedule of the next 2 weeks, the check mark being where we are today. The day after, or excuse me, a week after next Tuesday, a week after tomorrow, Tuesday, will be our next test. So in some sense, that's coming into the foreground. Just a remark with homework as sort of will be standard or has been standardly paced, but just so we're all on the same page, there's going to be a homework assignment on Thursday, and then one on Sunday as well, ultimately leading into the test. As has been the case with tests, the day before we'll run a review session, and then ultimately what that means is during this week we will round out the course material that will ultimately lead to the test. And in terms of the content leading to the test, just so that we're sort of aware of this, I've posted these things for every test so far, topic outline, and then a timed practice. The topic outline, expect that tomorrow, and the timed practice, expect that on Thursday. And ultimately that will give you the additional resources that will help assist you in your test preparation methods. Any questions about what lies ahead in this course before we jump into the math though? Yeah.
We'll test 2 stuff we put on Canvas.
Say that one more
We'll test 2 stuff we put on Canvas.
Oh yeah, good point. So we'll test 2 stuff we put in Canvas. Yeah, someday this week. I haven't gotten around to it, but I'll do that one day this week so that you can have a crystal clear image of what your grade is. Other questions? All right. So, today we're going to be in section 5.3, which relates very directly to things that we've seen so far. And section 5.3 is, in some sense, looking at sine, cosine, and the unit circle from a new perspective. I mean, new may even be too strong of a word. I could almost go with different here. Because we've looked at mathematical objects from this new / different perspective before, but we're simply going to look at sine and cosine with respect to the unit circle through this perspective now. That may not make any sense, but it will as we go through today. So, to gear us up for this discussion, let us remind ourselves concisely what we have learned to this point related to trigonometry. So, interesting ideas, important ideas that relate to what we've seen. First, 45, 45, 90 triangle. This is the triangle, which is both a right triangle and an isosceles triangle, a triangle with 2 equal angles, 2 equal sides. You could call each of the equal sides of side length 1, just for simplicity, and if you would do so, Pythagoras yields square root 2 for the additional side, namely the hypotenuse. The hypotenuse always the longest side in any right triangle. 30, 60, 90 triangle. Smallest angle 30, mid-size angle 60, full-size angle 90. You could call the smallest side to be of length 1, and recall whatever we went through deducing the other side measures. If you chop that 90-degree angle into a 60 and a 30, what you show is that the hypotenuse is ultimately a pair of unit lengths. The hypotenuse is of length 2. As soon as you get this, Pythagoras your way to the other side, square root 3. What then we saw was that if you take any triangle, not just these 2 triangles, but any triangle, you could superimpose that triangle into xy space. And if you did, that triangle could show up in the positive x-axis, or in the positive region of the plane, where the x's and the y's are positive. And what we observed was, if you took all triangles and you just tried to normalize things, you could put the triangles in a copy machine to where they would shrink in size to where the hypotenuse was of length 1. And if you did such a thing, then any point which would correspond to the location of the hypotenuse of the triangle, well, the far side of the hypotenuse of the triangle, the far point along the side of the hypotenuse, well, this point over x up y is going to correspond precisely to looking at this angle t and saying, well, x is not just anything within this triangle, it's the cosine. Cosine adjacent over hypotenuse. The adjacent side to our angle is the one that's next to but not the hypotenuse, whereas the opposite side is the one that's, well, opposite. Adjacent over hypotenuse, cosine. Cosine, x over 1. X over 1, just x. The x coordinate for our point is the cosine of our angle. Just as well, y over 1, opposite over hypotenuse, that's sine. We can take any point that is on this circle centered at the origin of radius 1 and interpret its point as a cosine and a sine. A cosine and a sine according to an angle. Now, how do we measure angles in the unit circle? Rather than simply using degrees, which of course we could, the standard method of choice is to measure an angle based on how far you have to walk around the unit circle. So this particular angle we would not measure as t degrees, but we would measure in terms of the length of the walk to get to the point along the unit circle. Now the thing to remember with that is going all the way around the unit circle is going all the way around the circle of radius 1. All the way around any circle is 2 times pi times radius. So if radius is 1, all the way around the circle is 2 pi. Well, if all the way around the circle is 2 pi, that says what? 360 degrees is 2 pi. Well, then you could simplify that down to be 180 degrees is pi. Going halfway around the circle is pi radians. Now, we built up from that because we noticed that if you start looking with respect to, say, a 30-degree angle, a 30-degree angle could be rephrased in terms of the length of the arc along the unit circle, because if pi radian is 180 degrees, 30 degrees, which is a sixth of that, would be a pi over 6 angle. 30 degrees, as you know, is a fairly small opening, so you could consider that to be approximately like so. So this is a point at an angle of pi over 6, because the length of the walk to get to that point along the unit circle would be pi over 6. Now the question becomes, what are the x and the y coordinates associated with this point? But well, the x and the y coordinates associated with any point on the unit circle is just the cosine and the sine of the angle associated. So in this case, the x coordinate, well, as it always is the cosine. In this case, it would be the cosine of 30. What's the cosine of 30? Adjacent over hypotenuse, square root 3 over 2. The y coordinate, as it always is for any point that's along the unit circle, is going to be the sine value associated with the angle. The angle here is pi over 6, 30 degrees. The sine, opposite over hypotenuse, 1 over 2. But now, from this point that we have along the unit circle, I claim we can deduce completely 3 more points off of this point, simply by reflecting. First, reflect from right to left. You'll get a point out here that will not change its vertical position, that will still be a half. But horizontally, we went from right to left, from positive to negative. Now the question becomes, what is the angle associated with this? How far is the walk along the unit circle to get to this point? Well, note, by virtue of reflection, that pi over 6 angle will also exist off to the left. And that pi over 6 angle will tell you how much less than halfway around the circle you'll have to walk. Because you don't walk halfway around the circle to get to this point. You walk halfway around the circle less the amount of angle that we have described with that green marking. Well, that would be what? Pi minus pi over 6. Because all the way halfway around would be pi, well, all the way halfway. Halfway around would be pi. Halfway around minus pi over 6 would get you to that point. But then how do you take pi minus pi over 6? Well, anytime you add or subtract fractions, you need a common denominator. Think of pi as 6 pi over 6. 6 pi over 6 minus a pi is 5 pi over 6. Reflect again. Now, down at this point, compared to the point we just drew, the x position has not changed. Still minus square root 3 over 2. The y position has reflected, gone from up to down. So now we're at minus half. It makes sense that we have coordinates negative and negative here because we're left and down. The question becomes, what's the angle associated with this? Well, check it out. This angle is completely in a straight line from the pi over 6 angle, which means moving pi over 6 and then moving further to get to this point, the amount of further movement is 1 halfway around the circle. The amount of further movement is pi units. So if we go to pi over 6 and then go pi more units, we would go to pi over 6 and then go halfway around the circle, which will end up exactly where this point is. What's pi over 6 plus pi? Again, adding fractions. The pi you could think of as 6 pi over 6. This would be 7 pi over 6. One remaining reflection. Over here, this would be where the x is positive, square root 3 over 2, but the y is negative, minus 1 half. What's the angle associated with this? Well, you're going to have to do a lot of walking to get to this point, because you're going to have to walk almost all the way around. Just like we did the last time, well, you could walk 5 pi over 6 to the point that's exactly opposite it, and then you could just walk however far you have to walk to go halfway around the circle. But to go halfway around the circle would be pi in measure. So we go 5 pi over 6, but then we add in a walk of pi. Because going 5 pi over 6 would get us to this point that's off here to the top left. Going in additional pi units would get us in a straight line, but on the opposite side of the circle. And add that together, that's going to be 11 pi over 6. Another observation that we made, which I want to sort of add this observation in now at this point, is that every positive angle that we have discussed here, which positive being moving from the x-axis counterclockwise, you could start at the x-axis and walk in the opposite direction. And as you would expect, walking in the opposite direction will correspond to angles that instead of being positive were negative. So just like pi over 6 was this first angle that you got to whenever you walked around in the counterclockwise direction, the first angle you get when you walk clockwise would be this guy down here at 11 pi over 6. So thought from the perspective of negative angles, this guy would be negative pi over 6. It's the same amount of walk down as you would walk up, the same amount of walk you would go clockwise as counterclockwise. The second angle you get to going counterclockwise is 5 pi over 6. So going clockwise, this would be negative 5 pi over 6. This being the second one you would reach, going counterclockwise, not the first point, but the second point down here to the bottom. Going around going around counterclockwise, the third point you reach is negative 7 pi over 6. Going around clockwise, the third point that you reach, negative 7 pi over 6. Going around counterclockwise, the fourth point you reach is 11 pi over 6. Going around clockwise, the fourth point that you reach is negative 11 pi over 6. Questions on that? Pi over 4. A pi over 4 is a 45-degree angle. How do you know this? Well, take 180, divide it by 2, and divide it by 2 again. You'll get what? Down to 90, and then down to 45. So this guy here, corresponding to a 45-degree angle, is going to have x and y values corresponding to cosine and the sine of 45. But when you look at the 45-degree triangle, the sine is 1 over square root 2, so is the cosine. So cosine, 1 over square root 2, sine, 1 over square root 2. I tell you what, rather than going point by point by point by point, let's nail down all 4 points right from the go here that we can work with. We've got the 1 already. There's 3 more by virtue of reflection. Here, off at this point, we're left and up. So this is going to be minus 1 over square root 2, 1 over square root 2. Negative with respect to x, positive with respect to y. Reflect again, down here, you're going to have negative with respect to both. And go off here to the, down to the right, positive, that's the x coordinate, down, negative, that's the y coordinate. So then the question becomes, well, what are the angles? Well, how do we get to the next angle? To get to the next angle, the length that we would have to walk to get to this position. It's not walking halfway around the circle, it's walking less than that. And in fact, it's walking less than that, exactly the amount less of a pi over 4, because the angle reflects. So you don't walk halfway around would take you all the way to here, you walk less than that. So it would be pi minus pi over 4. And of course what? Pi minus the fourth of a pi is just 3/4 of a pi. So this is 3 pi over 4. How do you get to the next one? The next one is a straight line away from a pi over 4. So this is a pi over 4 plus a pi. A pi to get you to the other side of the circle. But pi thought of fractionally with the denominator 4 is 4 pi over 4. 4 pi over 4 plus a pi over 4 is 5 pi over 4. What about the next guy? The next guy is a straight line away from 3 pi over 4. So if 3 pi over 4 is what it is, add in an additional pi, and you'll get to where you want to be down in this bottom right. Because, well, 2 things that line in a line, opposite sides are a pi apart. 3 pi over 4 to get to the 1, another pi to get all the way, that's 7 pi over 4 added together. But of course the positive measures would be the negative measures going around in the opposite direction. So 7 pi over 4 could be negative pi over 4. If you thought of walking down initially instead of up, if you thought of walking clockwise instead of counterclockwise. So what, it goes from pi over 4 to 3 pi over 4, so going in the opposite direction, clockwise it would go negative pi over 4 to negative 3 pi over 4. The third point, walking counterclockwise, is 5 pi over 4, so walking clockwise, you have negative 5 pi over 4. And the fourth point, walking counterclockwise, is 7 pi over 4, so walking counterclockwise, the fourth point will be negative 7 pi over 4. What's the value to having gone through all of this work? The value is, if you want to know the cosine of 7 pi over 4, you know it. It's just the x-coordinate, 1 over square root 2. If you want to know the sine of 7 pi over 4, you know it. It's negative, 1 over square root 2. What if you want to know the secant of 7 pi over 4? No sweat, take the cosine, flip it. What if you want to know the cosecant? No sweat, take the sine, flip it. What if you want to know the tangent? No sweat, take sine over cosine. What if you want to know the cotangent? Also, no sweat, take cosine over sine. That holds for every angle that you have drawn currently. You want to know the sine of negative 5 pi over 6? No sweat, negative 1/2. You want to know the cosine of 5 pi over 6? No sweat, negative square root 3 over 2. Because the cosine of any angle is always the x-coordinate associated. Questions on this? Last pictures. Pi over 3. Pi over 3 corresponds to a 60-degree angle. Because, well, we've done the 30 already, right? We've done the 45. Now we got to do the 60. The 60 is a third of a 180. What's this guy going to look like? Well, first, the 60-degree angle is 2/3 the way to 90. So it's the most open of the 3 that we've considered. What are its values going to be for x and y? Well, as any point on the unit circle, it's going to be the cosine and the sine. What's the cosine of 60 degrees? The cosine of 60 degrees is going to be adjacent over hypotenuse, 1/4. over 2. What's the sine of 60 degrees? That's opposite over hypotenuse, square root 3 over 2. Let's get the points. Reflect. Negative 1/2, square root 3 over 2. Reflect again. Now we're reflecting down. Negative 1/2, negative square root 3 over 2. Reflect back to the right. Now the x-coordinate is going to become positive, and you get 1/2, negative square root 3 over 2. What are the angles? Well, to get to that second point, you won't go all the way halfway around. You'll go not quite that far. And in fact, the not quite that far that you will avoid is an angle of measure exactly pi over 3. So to get to this angle, you don't go pi, you go pi over 3 less. And what is that? That is 2 pi over 3. Because of course pi is 3 pi over 3, and 3 pi over 3 minus a pi over 3 is 2 pi over 3. What about the next angle? The next angle is a pi away from pi over 3. It's straight and in the opposite direction of pi over 3. So if you take a pi over 3 and you add a pi, you're taking pi over 3 and adding 3 pi over 3, that's 4 pi over 3. And this last guy is a pi away from 2 pi over 3. So a pi away from 2 pi over 3 is 5 pi over 3, because you add in 3 pi over 3. What would those angles correspondingly be with respect to negative movement? Instead of going counterclockwise, what if we went clockwise? Well, just like it goes pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, it's going to go negative pi over 3, negative 2 pi over 3, negative 4 pi over 3, negative 5 pi over 3. For good measure, I'm going to point out, no pun intended, 4 more positions along the unit circle. These are the most basic of the positions, sometimes referred to as the quadrantal angles, because they lie on the quadrant lines. Don't move at all around the unit circle. You will go 0 units around the unit circle. Where will you be? You will be at the point over 1 of 0. Go not halfway around to the opposite side of the unit circle, but half of that. That's 90 degrees. That's a pi over 2. That's over 0 up 1. Cosine pi over 2, 0. Sine pi over 2, 1. Cosecant pi over 2, flip 1, 1. Secant pi over 2, undefined. Go halfway around the unit circle, you've gone pi around the circle. What's the value associated with this point? Well, this is left 1 of 0. Cosine pi, negative 1, sine pi, 0. Next, 3 pi over 2. This is a pi away from pi over 2. Add pi to pi over 2, you get 3 pi over 2, because you add in 2 pi over 2. What's this point? This point is over 0 down 1. Cosine 3 pi over 2, 0. Sine 3 pi over 2, negative 1. Cosecant 3 pi over 2, also negative 1. Just flip negative 1. Secant 3 pi over 2, undefined. Interesting. All right. Questions on what we did there? What's that? What's this? I mean, whatever. I call it quadrantal angles. I mean, you could say that if we're doing it similar to the others, we just moved around at a rate of pi over 2 instead of at a rate of pi over 6 or pi over 3.
And these values are obviously unchanging, because I know we had, it's like, what's sine cosine of 16 pi? That would just be going around, like, what, like 8 times?
Yeah,
So you'd
yeah,
just
so
be getting
pi,
yeah.
2 pi, 3 pi, 4 pi, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16. So 16 pi over here.
Yeah.
Yeah. Does that answer your question?
Yeah.
Okay, good. Other questions? All right, now you say, Mark, well, maybe you didn't say this, but you could think it at this point. You said sine, cosine, unit circle from a different or new perspective. This is not different or new. This is precisely what we did last time in class. Well, yes, it is, but I also promised you last time in class that we would work and familiarize ourselves with these guys, because these guys are at the heart of everything that we do in this chapter. So, what is this new or different perspective? I want to do here is start collecting values for sine and cosine. So here's what I want to do. We are going to plug in, values for t, values for our angle, and then we are going to see what the corresponding values for sine t are going to be. We're just going to say, okay, we're going to look at all these points that we have around the unit circle, and we're going to start collecting sine values. Because you can. When t is 0, what is sine? Well, t is 0 is when you've not gone at all around the unit circle. The sine there is going to be, as it always is, the y-coordinate, because the y-coordinate is the opposite value in the triangle whenever you draw in the triangle with respect to the origin. Opposite over hypotenuse, y over 1. Sine value is the y value off the unit circle, so the sine of 0 is 0. Next, we're going to start walking our way around the unit circle. The next point we get that we've described is 30 degrees, pi over 6. What's the sine value at pi over 6? The sine value, as it always is the y-coordinate, 1/2. Next value, 45 degrees, pi over 4. What is the sine value, as it always is? 1 over square root 2. By the way, if you put this in a calculator, just to get a rough idea of what this is equal to, let me put a rough equal sign. This is like 0.707. Next, pi over 3, because what, 30, 45, 60, sine value, square root 3 over 2, and this guy's about 0.86, just for reference. I mean, think about this, guys, this makes sense, right? Because as you're moving along the unit circle in this counterclockwise direction, we're tracking with sine the y-coordinate, and the points initially ascend, right? So these values are getting larger and larger as the position of the point is going up and up. The values of the y-coordinate are ascending. But the values of the y-coordinate aren't going to ascend forever. In fact, they're going to reach a maximum at pi over 2. Because at pi over 2, you're now atop the circle, and there's no summit higher than that, with a value of 1. Continue along. What's the next point we'll get to? Among the points that we've accurately described, the next point is here at 2 pi over 3. Square root 3 over 2, which we know is about 0.86. Well, we don't. I told it to you. It's there for the taking. Okay, what's next? As we continue working our way, cycling around the circle, the next point we'll get to that we've accurately described is 3 pi over 4. 1 over square root 2. The next point is that 5 pi over 6 with respect to the 30-degree angle, and that's going to have a y value of 1/2. Note, these values have a sort of mirror effect here because we initially ascended the circle and then we descended along the circle analogously. Working our way all the way to pi on the far left of the circle now, where the sine value is 0. We're tracking the y-coordinates here. We ascended up the mountain, then we descended the mountain. And now we're going to actually go into the valley along the bottom side of the unit circle. If we continue this table, from pi, where's the next point we get? The next point that we've accurately described is 7 pi over 6. 7 pi over 6 along the 30 degree. That has a y value, a sine value, of -1/2. The next point we would get to is associated with pi over 4 down here at 5 pi over 4. That guy's -1 over square root 2, which we know is about -0.7. The next we get by cycling around would be at 4 pi over 3. And that would be a value of negative square root 3 over 2. As we're descending down the circle, the values of the y-coordinate are getting more and more negative, but they don't get more and more negative forever. In fact, they get more and more negative to the point where you get to the very bottom of the circle. When you get to the very bottom of the circle, that's 3 pi over 2. You've got a value of -1. we're almost all the way around. There's 3 more values to get us all the way around. And so what are those? Next, we get to the 5 pi over 3. That's going to be at minus square root 3 over 2. After that, we'd be at the 45-degree angle equivalent, which would be 7 pi over 4 at a y-coordinate of 1 over square root 2 negative. We then get to the one that's equivalent to the 30-degree, namely 11 pi over 6, which is at a minus 1/2 y-coordinate. Hell, if you wanted to consider it, what would happen when you get all the way back around? When you get all the way back around, you will have walked around 2 pi. Going all the way around the circle is 2 pi because, well, if the circle's of radius 1, 2 times pi times radius is 2 pi. So going all the way around the circle gets you back to a sign of 0. These values kind of make sense when you think about it. Initially, the sign values are getting bigger as you climb the circle, which the y-coordinate increases. Then, as you continue along, you eventually start descending to the point where you get at pi. After pi, the y-coordinates start to become negative to a point, though. At the point 3 pi over 2, they become as negative as they will be. And from 3 pi over 2 to 2 pi, you're going to start rising again in terms of your y position. Your y position is becoming less and less negative. But now, with that full breath of steam that we sort of just let off there, we collected all of these sign values. We collected them in this table with like a t and a sine t. Have we ever before collected values in a table, looking at inputs and looking at outputs? Hell yeah, right? Like pick your poison there. In many, many cases, with parabolas, with absolute value functions, with cubic functions, with lines. What can you do when you have values like this in tables? Very naturally. You can take every input and every output, and you could construct an ordered pair. And you could take that ordered pair, and you could develop a graph. So here, let's do a graph of the sine function. I claim we have the skills to do it. Well, it's not even the skills, we've got the data to do it. Because the data is sitting right here for us. Now, here's what's interesting when you start looking at the data. Some takeaways. Since the sine value is recording the y position on the unit circle, and we saw this as we went through the table, the output side, on the right side of the column, goes no higher than 1 and goes no lower than minus 1. We already have bounds here on our function. Our picture, the output, right? The output is on the vertical axis, the input on the horizontal axis. We happen to be using the t-axis and the f of t-axis. But so be it. We previously used the x-axis and the f of x-axis. It's completely analogous. I'm merely using t here as opposed to referring to x because the x is what we standardly think of as the points on the unit circle, but it's the same idea here. But now, how can we proceed? Well, there's going to be a point at 0, 0. And in fact, as you start looking at these points, let me just go down to the point where we're at 1 with our function output. That means when we go over to pi over 2, we're up here at 1. And along the way, where did we go? Well, pi over 4 was halfway between the origin and pi over 2 on the x-axis, but on the y-axis, the value was up here at 0.7. So it was closer to 1 than it was to 0. Okay, now, mind you, I've skipped the 1/2 and the square root 3 over 2 value. They're in there somewhere, right? I mean, you could draw in pi over 6 and put in a half, and you could draw in, if you wanted to, you could draw in pi over 3 and put in 0.86 approximately. But I'm focusing on the pi over 4 and the square pi over 2 because those are sort of easier to delineate by virtue of the fact that one is half of the other. Okay, now, the next simplest point to work with was over pi. Now, how far is over pi? Well, if pi over 2 got you to this distance, well, pi is going to be the same distance again, right? Because half of pi plus another half of pi gets you to pi. So moving horizontally, we're going to be out here at pi. What was the function value here? 0. What were the corresponding function values? They were symmetric as to what lied over to the left. So we've got sort of some symmetry here, right, as we saw in the values as we're rising up the unit circle and then rising down the unit circle. Now what happened after we went pi units around an angle measure along the unit circle? Now, instead of going up the unit circle, now we're going to start descending to the bottom, the valley of the unit circle. So the sign values, the y coordinates, are going to be down here below the axis. In particular, working our way out to 3 pi over 2, the sign values are going to work all the way down to -1. On our way back up to the x-axis, that was on our way to 2 pi. And by the time we get to 2 pi, we'll indeed be back to the back to the t-axis, because the function value is 0. 0 would be along the axis line, neither up nor down. If we start tracing this in, what this is going to look like, we're going up to the top of the unit circle at pi over 2, down back to a sign value of 0, where the y is 0 at pi, going down the unit circle until we hit the bottom of the unit circle at 3 pi over 2, and then going back up the unit circle to 2 pi. Let me ask you a question. Well, first off, before I ask a question extending from this, any questions on what we did here? What in effect did we do? We just took this smattering of points and threw them up here on the picture. This smattering of points that came from our knowledge of a variety of points off the unit circle. So here's my question to you. What would happen if we would extend along the t-axis beyond 2 pi? What would happen if we would extend to, let's see, we were going off at pi over 2, pi, 3 pi over 2, 2 pi. What if we kept counting up by pi over 2s? So we went from 4 pi over 2, which is 2 pi, to 5 pi over 2. Right, because this is like 1 half of pi, 2 halves of pi, 3 halves of pi, 4 halves of pi, 5 halves of pi, here's 3 halves of pi. Or, excuse me, 5 has, that's, 5 has 6 halves. There we go. 6 halves, which would be just 3 pi. And then another half would be 7 pi over 2, and another half would get you all the way to 4 pi. What's going to happen? Think about it. To get this picture, we were tracking the y coordinate as we went around the circle. But now once you get to 2 pi, what's going to happen? You're going to go around the same exact circle. So what was happening to the y coordinate as you went from 0 to pi over 2 is going to be the same thing that happens as you go from 2 pi to 5 pi over 2. It's the same piece of the circle. So this piece that was between 0 and pi over 2, hell, this piece that was between 0 and pi is going to be the same as the piece between 2 pi and 3. And this piece that was between pi and 2 pi, which is down here, going along the bottom of the unit circle, that piece is going to be the same as 3 pi to 4 pi. What happens after you get to 4 pi? Well, after you get to 4 pi, you will have gone around the unit circle twice. If you keep walking around this unit circle, the thing's going to repeat. So, going on from 4 pi, the function is going to repeat accordingly. Now, I drew this arrow pointing up because I simply ran out of space. But you know that this function is not going to ascend off to infinity. It can't. It's the sine function. And the sine function, recording the y coordinates off the unit circle, simply can't extend north of 1 or south of -1. So it may look like this thing's going off to infinity, but no, it is not. You can go off to the right to infinity, but this thing is going to undulate up and down and up and down and up and down all the way. It's almost like a pendulum going side to side to side to side. As this thing goes up and down and up and down, it has that same sort of periodic motion.
The wavelength.
Yes, precisely. What if we walked backwards? check it out. What if we went here, back to negative pi, from 0 to minus pi? Well, 0 to minus pi would be walking around in the negative direction instead of going around counterclockwise, starting up. We're going to start our journey down and walk clockwise. Well, the first pi units of walk are going to be the first half of the circle, which is the half in the valley. So this thing is going to give you the half in the valley. And what if you continued walking? Well, you'd now be along, if you continue walking the negative direction, after going down the bottom half, the valley of the circle, now you're going to be going along to the summit of the circle. Same story. The thing just repeats over and over and over again. Questions on this? If you wanted to, you could do the table with the smattering of values, looking at the cosine values. But if you think about it, the symmetry of the circle is going to yield a similar shape on the function. Because if you're going around the circle this way, looking at the cosine function, now when you're looking at the cosine function, you're not looking at the y-coordinate, you're looking at the x-coordinate. But so be it. If you're looking from the perspective of what the x-coordinate, then the values are positive over here to the right and negative over here to the left. But it's still the same action as you're moving around the circle. So let's take this. I claim, with what we've done over here, noticing the symmetry of the circle, we can actually cook up a graph of the cosine function. Cosine values are the x-coordinates. The x-coordinates also, like the y-coordinates, only go between 1 and minus 1. Here, x-coordinates, cosine, between 1 and minus 1. You can never go farther than the farthest right point on the unit circle, which is up 1. You can never go farther than the farthest left point, which is minus 1. The cosine function looks at the x values. We're going to start our journey at an angle of 0. At an angle of 0, what is the cosine's value? 1. So the cosine function, instead of starting at the origin like the sine function, starts up at 1. But now, where do you go as you move along? You move along to pi over 2. When you get to pi over 2, what's your cosine value? The cosine value, the x-coordinate, is 0. Keep moving along to pi. What's your x-coordinate? Your x-coordinate is down at minus 1. That's where you're the farthest left. 3 pi over 2, keep moving along the axis. 3 pi over 2, your cosine is going to be 0. When you go all the way around to 2 pi, what's your cosine going to be? Your cosine is going to be back up at 1. Draw this in with the same shape as the sine function, because this thing's going to act identically, merely moving around the circle. The thought with this picture being, with respect to the x-coordinate starts positive, then you get to the axis and the x-coordinate 0. Now, for half of the circle, you're off to the left, so the x-coordinate is negative, and for the last quarter of the circle, you go back off to the right, where the x-coordinate is positive, going off to the point that is ultimately 2 pi, all the way off to the right, all the way at a cosine value of 1. If you keep cycling around the circle, you're going to keep cycling your cosine values accordingly. This value here at pi over 2, negative pi over 2, excuse me. This value here at minus pi. This value here at minus 3 pi over 2. It's a complete. There's nothing more, in some sense, cyclical than going around a circle. It literally recycles every time. So if the cycle is to go down and then up, as you go to the right, it's going to go down and then up. And if going left, the cycle is to go down and then up, it's going to go down and then up at that exact same rate as you go around the circle. Questions on this? Just a thought. I'll plant this in your mind. We'll do examples related to this next time at the start of class and through the entirety of class. But just a thought. What if you didn't want to look at the cosine function, but what if you wanted to look at 3 plus the cosine function? Shift it up 3. What if you don't want to look at the sine function, but you want to look at the negative sine function? It's going to take everything that's up down and everything that's down up. It's going to reflect. What if instead of looking at the cosine function, or the cosine t function, you wanted cosine of t minus pi over 2? Well, that's going to shift the thing to the right, pi over 2 units. All these things that we talked about with graphs and shifting up and shifting down and shifting right and shifting left, and reflecting this way, reflecting that way, can be applied to these guys. I just want to plant that seed in your head now, knowing that we'll go through examples next time specifically in class. Questions on that? Hopefully this is feeling slightly less mystifying. And the graphs, which we've only done now here for part of a day, that's going to feel even more mystifying in time. But at this point, it is what it is. All right. So we got 4 minutes here left together, so I'm going to pass out quizzes for today. With your notes, it's totally doable. Interesting.